So now that we have discussed about solution of a quadratic equation in its most basic definition, let's see what are the various methods through which we can find the solution of a given quadratic equation. There are three important methods identified in mathematics for solving a quadratic equation. So to start with, the methods for finding the solution of quadratic equation, we have three basic methods in finding the solution of the quadratic equation. One is the first method called the factorization method. And secondly, complete square method, and thirdly, it is the discriminant formula method. It's called the discriminant method. So these are the three basic methods through which we get the solutions of given quadratic equation: the factorization method, complete square method, and discriminant method. So let's see each of them step by step, to start with the factorization method. So note, in each of the methods, a given problem, if it is given to use with particular method, we use only that particular method. If nothing is mentioned, the choice is left to the student to use any method which is easier in their own respective ways. So it's a very important note I make here, that if the method is specifically mentioned, then use that method only. Then use only that method, because it is with the intention of using specifically with that method is how we are going to proceed. So initially, to start with the factorization method. So let's start with factorization method. How to solve a given quadratic equation using the factors or the factorization method. The first method, the factorization method. The factorization method is, the word itself states about factors. So we identify the factors, and that helps us in solving the quadratic equation. So let me take an example problem and let's see how factorization method can be solved with that respective example problem. For example, I take an equation equals 1 by 6. Now this is directly not a quadratic because I have linear x and the power of x here is -1, which is non-negative integral. We have to make this a quadratic by further simplifying, and just let's see if we can test this for a quadratic equation. That's the first thing you must identify, that whether a given equation is quadratic or not. So let's see if this is quadratic or not a quadratic equation. To start with, I can take the LCM of x and 1 over 3x, which comes out as 3x. So this gets multiplied with 3x times of x is how we do the LCM part, and this with 1 times of 1, this equals 1 over 6 is how I get the LCM of x and 1 and 3x done out here. Next, x times of 3x is 3x squared minus 1 over 3x is 1 over 6 is how I get the simplified part of the above equation. Now this, on further simplification through cross multiplication, gives me 6 times of 3x squared minus 1 is 1 times of 3x, which needs to be further simplified. Therefore, when I expand this over the brackets, I get 6 times of 3 is 18x squared minus 6 is 3x. Then this, with all terms to the left and only 0 to be kept on the right, gives me 18x squared minus 3x minus 6 equal to 0, which can further be simplified by cancelling each of 3. So I divide the whole equation with the number 3 so that I get 18 by 3 as 36 x squared minus x minus 2 equal to 0. Because I divide whole of this equation with 3, I get 3 6 18, 3 1s minus x, 3 2s minus 2. Now this is clearly a quadratic equation which is obtained from the given problem. Therefore, I have to solve the given quadratic equation, and the roots or the solution of this quadratic equation is nothing but indirectly the solution of the given problem, is how we understand the concept. So let's see how we can solve the given quadratic equation using the factorization method. So the quadratic here is 6x squared minus x minus 2 equal to 0. Now the first rule in solving the factors for this given quadratic equation using the factorization method is that we always multiply the coefficient of x squared with the constant term. Always, in any quadratic equation, we multiply the coefficient of x squared with the constant term. So I get this. Of course, I don't take the sign into consideration, but apart from sign, I just find the factors as 2l. Now next, I want to find all the possible factors of 2l, which I start with 1. Let me identify the value 2l with all its possible factors. Initially, 1 times of 2l is 2l. Next, 4 times of 3 is 2l. And 6 times of 2 is also 12. So these are the possible factors for 12. So once we identify all the possible factors, then we try to consider the middle value, which is the coefficient of x. Now here, the coefficient of x is minus 1. Therefore, when I add or subtract the factors, I need to get minus 1. So when I add 1 and 12, I get 13. It doesn't work out here. When I subtract 1 from 12, I get 11. Still, it doesn't work here. When I take 6 and 2, 6 plus 2 is 8. Doesn't work out here. 6 minus 2 also is 4, which doesn't work here. But when I take 4 plus 3, also it is 7. It doesn't work. But when I take 3 minus 4, it is minus 1, which works here. Because the coefficient of x here is minus 1. Therefore, these factors will help me in factorization. 3 minus 4 equal to minus 1. So this gives me 3 minus 4 equal to minus 1, which is nothing but the coefficient of x, which helps in factorization. This is how we identify the concept in factorization method. Therefore, when I split this, minus x can be split as plus 3x minus 4x minus 2 equal to 0. Because 3x minus 4x is minus x. So indirectly, minus x, I can write it as 3x minus 4x, so that the factors 3 and 4 as obtained for 12 here will help in factorization. So indirectly, when I split x in the form of the factors of 12, then only factorization is possible through the factorization method. Very important to note here. So then next, I pair the first two and the last two together. The next concept is pairing them together so that this pair, I can take 3x common I need to take the maximum possible terms which I can take common out of this pair, which is 3x, which I can take common out of these two terms. So finally, when 3x is taken common, I get this to be 2x plus 1, which comes inside the brackets. Similarly, I can take minus 2 common out here, where the remaining terms inside would be 2x plus 1 equal to 0. Now sometimes there is a possibility that we do mistakes in taking the terms common. So it's very important that to recheck whether what we have taken common out here is right or wrong. Therefore, in order to recheck, I re-expand this to see whether I get the similar terms. 3x into 2x is 6x squared, 3x into x is 3x. So what I have taken common here is very much correct. It is about verification. Similarly, minus 2 times 2x is minus 4x, right? Minus 2 times 1 is minus 2, so I'm right. So rechecking through the expansion for getting the original terms is very important here, because many students do mess up in doing mistakes in taking something common out here and here. So verification is a must. Make a note. Next, I find that the whole of 2x plus 1 is again common out of the first term and the second term taken on the whole. Therefore, this common term comes out of both the terms, so that the remaining terms, when 2x plus 1 comes out, then I have only 3x left inside, and this comes out, then only minus 2 is left inside, so that I get 2x plus 1 into 3x minus 2 equal to 0 is how I get when the whole of 2x plus 1 is taken out. Now I have the product of two factors equal to 0. The product of two factors is 0 makes me understand through the factor theorem that each of the factor can be 0. Either this equal to 0 or this equal to 0 is the factor method. So that implies 2x plus 1 is 0 or 3x minus 2 is equal to 0. Either this equal to 0 or this equal to 0 is what, when combined, gives both product equal to 0. It's not compulsory that both of them should be 0. Even if one of them is 0, then 0 multiplied to any non-zero number will give back 0, is how we understand this factor concept. Next, when 2x plus 1 equal to 0, then what is the value of x? It's clearly minus 1 over 2. And then when 3x minus 2 equal to 0, then clearly I get 3x equal to 2. That implies x is 2 over 3 and x is minus 1 over 2. Therefore, solution of the given problem is x equal to minus 1 by 2 and 2 by 3, indirectly written in this form, or x equal to minus half and x equal to 2 over 3 are the required solutions of the given quadratic equation, indirectly, not in its quadratic form. The respective equation given as x minus 1 by 3x equal to 1 by 6 reduced to a quadratic equation and hence solved using factorization method is how we do for any quadratic equation. Now, how do I know that the values which I have obtained are right or wrong? How do I verify? Verification. We verify this by substituting them in the equation back to see whether I get equal to 0 for the given equation. So I can substitute the value of x as this or this in either this equation or the original equation. So let's substitute in the original equation. My original equation out here says that x minus 1 over 3x is 1 over 6. So let me see if this first value of x equal to minus 1 by 2 satisfies this equation. So substituting x equals minus 1 over 2 in this, then let's see if I get the left hand side equal to the right hand side. My left hand side, which is x minus 1 over 3x, gives me x minus 1 over 3x is what I get and when I simplify this, I must get the right hand side, which is 1 by 6. So let's see if this simplification leads to 1 by 6. Now here I get the LCM as 6, which 2 times of 3 times of 1 is minus 3, plus 3 times of 2, 2 times of 2 is 4, which finally gives me 4 minus 3 is 1 over 6, which is clearly the right hand side of the equation. Therefore, the value of x which I obtained is minus 1 by 2 is very much true or correct. Similarly, to know that the second value also is correct, equally I substitute x equal to 2 by 3. But before this, my x is minus 1 by 2 is fixed to be the solution of the given equation. So next, x equals 2 over 3 implies x minus 1 over 3x is 2 by 3 minus 1 over 3 times 2 by 3. This gets cancelled, and then finally I get 2 over 3 minus 1 over 2, which on simplification clearly gives 1 by 6. Therefore, the other solution which I obtained as 2 by 3 is also very much true to its best. This is how the verification is done for the given quadratic problem. Now, if the question is not specifically asked of verification, then this will be very time consuming, where I suggest you all to solve it very fastly on the rough notes and then check whether the answers you obtain are right or wrong, because time factor is very important when writing the examination. So this can be randomly checked without including the prolonged steps. So this is how the factorization method is used in finding the factors of the given quadratic equation. Now, in factorization method, the other important factor which we need to focus on is how we choose the factors. For the previous problem, it was quite easy to choose the factors, but sometimes the two different factors when added and subtracted give the same combination. Let's see how that can be overcome with an example problem. For example, I take the quadratic equation x squared minus 5x plus 6 equal to 0. Then, as we know that the factors are obtained for the multiplication of coefficient of x squared with constant, that is, when I take this with this, then I get 1 into 6 is 6. Then I find all the possible factors of 6. Then I see that the factors are 3 times of 2 and 1 times of 6, which give me the factors of 6. And interestingly, we need to see either when we add or subtract the factors, I must get the middle term, which is minus b, which is b, and negative 5. So clearly I see that 3 plus 2 also gives me 5, and 6 minus 1 also gives me 5. So this is a case of a tie. So which one are we going to use? Are we going to use the factors 3 and 2 or 1 and 6 is the biggest question out here, because 3 plus 2 gives me 5, equally 6 minus 1 also gives me 5. Now the puzzle comes out here. So let's also take both the things and see where the condition fails. If suppose I take here, for example, 1 and 6, then I can write this as minus 6x plus x 1x plus 6 equal to 0 if this is split along the two factors minus 6 and 1. Again, let me take the second factors 3 and 2, where this can be split as minus 3x minus 2x plus 6 equal to 0 when I use these two factors. So when the factors 6 and 1 is split with minus 6 plus 1, which gives minus 5, and the factors 3 and 2 when split gives minus 3 minus 2, which is minus 5, both are equally the same. But which one helps me in factorization is very important out there. So which one do I use? Do I use this or this is the biggest question. In factorization method, the most important note is I use this and I don't use this. This cannot give me the factors by factorization method, but this gives me the factors in factorization method. Why? What is the reason? Because this equation has 2 even minus signs and 2 even plus signs, but this has 1 odd minus sign and 3 odd plus signs. If you have even minus or plus signs, we can factorize. If you have odd minus or plus signs, we cannot factorize. So a very important note comes here. Choose factors which yield even minus signs and even plus signs, that is 2 and 2, or 4 plus or 4 minus. So even number of minus or plus signs should be there in case of this. 1, 2 plus signs, 1, 2 minus signs. But here 1, 2, 3 plus signs and only 1 minus sign. So this is the case of odd, this is the case of even. Therefore choose factors which yield even plus signs or even minus signs, or all plus signs or all minus signs, but you cannot use when you have odd or plus or odd minus signs. So choose factors which yield even plus or even minus is very important in identifying the factors in factorization method. In this example being, this can be used for factors, this cannot be used for factors. This is how we identify in factorization method.